objects. So in the previous videos, we've been introduced to objects such as strings and scanners. And in this video, I want to elaborate on what an object is. So an object is just a different way we can store data. But unlike a variable, we can store more types of data and we can do different types of things with objects that you can't do with a normal variable. So for example, a variable, we've described it as some type of box that stores a type of data. Now, for example, this integer 18 might be somebody's age, right? So this would be a variable. Now, an object can be thought of as a human, for example. So a human might be an example of an object. It can take, it takes a group of information such as age, name, weight, and it combines it under one common umbrella, right? So we have human, where a human will have some type of age, some type of name, maybe even a date of birth, height, weight, so on and so forth. All this different types of information. And furthermore, a human can perform tasks, right? They can talk, they can sleep. We can even calculate how many calories this person needs, right? So we have different tasks we can perform with this human. Now, these tasks are what we call methods, similar to the scanner class when we're getting input, .next line and .next int, and all of these different methods. There were tasks that the scanner class can perform. So an object can store information, data, and it can perform tasks, methods. Now, objects, so this is what this human right here is our object. Now, objects are what we call instances of a class. What do I mean by that? So human is actually a class, just like the programs we've been making so far. We do a class and then we name it like hello world and then we make a program. Similarly, our objects are derived from a class. So somewhere we can have our class human, right? And then inside here we have our program, right? We have our program, and then we close, we finish our program, and inside here we describe how our human acts. Now an object is what we call an instance of this class. Now what does that mean? That means it's using this class as a template. For example, in this class it might tell us that a human needs to have an age, it needs to have a name, and needs to have a date of birth, and needs to have a weight and a height and all this other different information. And then it needs to be able to perform certain tasks. It needs to be able to talk. He or she needs to be able to sleep. They need to be able to get the amount of calories they need. So these are the tasks that a human needs to perform. So the class is the template. It tells you what the human needs, but it doesn't assign any of the data. It doesn't give an age, it doesn't give a name or a date of birth. That's done when you create the object. So this object goes to the class, it takes it as a template, it sees what it needs in order to become a human, and it will then initialize the necessary data. So for scanner class, when we created our scanner class, somewhere in the Java library, we have a class named scanner. Somebody made a program called scanner class that we can use. And inside the scanner class, it's defined what kind of tasks it needs to be able to perform. So we have the next line, the next int, the next double, all these different methods that we have. And when we created our object, it looks at this scanner class, and it takes that as a template for us to use in our other program, just as a template. So anything we do with our scanner object does not affect the scanner class. Now that we know objects are instances of classes, let's talk about how we create an object. So to declare an object, it's very similar to how we declare a variable. We start with the class name, the class that we want to create the object from. So for example, in the case of scanner, we use scanner, and I will also use the human example for the case of human. Very similar to how we have a primitive data type to describe our variable, we have the class to describe our object. Next, we have our identifier name. Same rules apply as regular variable identifiers. And as a common practice, usually objects are started with a capital letter. You can start scanner with a capital letter. Scan is, I think, kind of the exception. I don't program scan as a capital letter. But when you're creating other objects like human, or when you're using your own objects, it is a common practice to use a capital letter to indicate an object. So that way you can differentiate between variables and objects. So here we've declared our two objects. And then next we want to initialize it. Initializing is just how we initialize anything else. We use the equal sign. Now here's where it differs. If you remember, we use the new keyword when we create our scanner class. And the same thing is for our person. And then next we restate our class name. And you can think of this as saying, I want a new instance of this class. So I want a new scanner class. I want this template and I want to create a new one. And then inside the parentheses is where you have your input information, right? So in the case of our scanner class, it was system.in. And this is a parameter for you to initialize your object. It needs to know what kind of data to start off with. So in our scanner class, it knows that system.in is the input it needs to know where to get the input from. In our human, for example, probably needs a name and an age at the very least, right? In order to define this human. So we have to start off by giving our object some type of information. Now once we have our object declared and initialized, now we can start using the methods inside the object. For example, in scanner class, we can start using scan.nextLine. And anytime we want to access a method from an object, we use this dot operator. And that dot means you want to access something from the method. And methods are always followed by parentheses, right? Now, for example, our human, we'll use person. And one of the methods that we said they might have is talk, right? So person.talk. And then inside these parentheses, we have our parameters. Now we need to think about, for example, what kind of input might a talk method require. It might require the message to be spoken. So hello, for example. So different methods are going to require different types of input. Some, like scan.nextLine, don't require any type of input. But others, like for example, our human class, the talk method, would require one parameter, which is the message that they want to speak. Now, if you remember, I said that string is an object, but we don't declare strings like this. We don't say new string or like we do new scanner or new human. Instead, we just initialize this string immediately. Why is that? Well, string is a special exception because strings are used so often. But behind the scene, what's actually happening is that it's being declared as an object. So when you do string str equals new Java, right? What's actually happening is it's doing this new string and then Java as its input, right? As its starting value. And this happens behind the scene, but it's happening every time you create a string. So you can do this first option where you do the new string and it will work fine. Or you can use the shorthand because strings are used so often. Now that we know how to declare objects and initialize them, I want to briefly talk about how they're stored. Because the way they're stored are slightly different from variables, and it leads to some interesting consequences. So for a variable, when we create an int age equals 18, for example, in memory, we have our age, and inside this cell is the value stored, right? So if I have another integer x and I set it equal to age, a new variable x will be created, and then it's going to look inside the age cell. It's going to see this number 18 and it's going to copy it into its own cell, right? But age and X are not linked in any way. For example, if I do age plus plus, age will increase to 19, but X won't be affected, and vice versa, right? But now if we get to objects, right? If we get to objects, the way objects are stored is they're stored by reference. What does that mean? So if I were to create a human right? So human person 1, and I were to initialize them the way we've initialized them above, in memory, this human will have a specific place stored for it, but instead of having the information stored in this cell, you have some type of address, memory address. Now you don't need to know what this number means, obviously, but this is an address. It's a memory address. It can be thought of like a regular address, a house address, a work address, anything. It points you to somewhere else in memory where it stores this type of information, right? So somewhere else in memory is going to be more space and it's going to store the information. For example, Bob and 18. So the person would have been declared with the name Bob and the age 18, right? Now let's say I make another object called person 2, right? So I want to make a second person, and I set him equal to person 1, right? Because I want to copy the information. I want these two people to have the same information. So person 2 is going to have a space allocated, and then it's going to go to person 1, is going to look at this information, and then it's going to copy this value into its own cell. Now what just happened is that person 2 didn't copy the information, it copied the memory address, which means now person 2 also points to the same object, the same Bob. Now what this means, if I manage to change this age to, let's say, Smith, now both of them are going to have that name changed, right? Person 1 and person 2 are going to have their name changed from Bob to Smith. They're not separate, they're the same thing. Because when I set person 2 equal to person 1, I didn't copy the information. No, I copied the memory address. So now they're both pointing, they both are pointing to the same thing, the same human object, right? And that means if I change the information on one, I change the information on both. So this is an important thing to keep in mind. Now, if we try doing the same thing with string, if we create string str1 and string str2, and we set the first one equal to Java, and we set the second one equal to the first one, we don't get this problem, right? So if I change string 1, I make it equal to C++, string 2 will still hold Java. And why is that? That's because strings are what you call immutable objects. It means you can't change them once they've been initialized. Now you might be thinking, well, I've been changing strings all the time. I can concatenate them, I can change their values. What do you mean I can't change a value? Well, you can change the value of a string, but you're actually creating a new object. What do I mean? So for example, I'll delete this for now. When I do this, string str1, I'm creating a specific place in memory, and inside is stored that memory address, and it's going to point me to the string, right? Java. Now when I do str2 equal str1, right, it's going to store this information in here, and now both of them both store Java. Now when I do string 1 equals C++, it doesn't change this object, right? Because this object can't change. Instead, what it does is it creates a new object that has C++, and it redirects, right? It redirects the original variable to point here. So now instead of 05x, it might be 056, it might be 057, right? So now it actually points somewhere else completely. So string 2 still holds the original variable, and that's why strings don't fall victim to this problem. So that was just an overview of objects. We went into more detail about what an object is, how it's an instance of a class, how it has methods, and how we can create objects using the new operator. And we even went into how it's stored in data and what we need to be careful with when assigning objects to each other, as we saw with the human example. Now, I still need to talk about methods, but if I don't want to make this video too long. So in the next video, I'm going to continue off talking about methods, specifically for the string objects, and we're going to show a few examples on BlueJ. So thank you for watching, and I'll see you in the next one.